Hello students, this is the sixth lecture of my course Dam Engineering. Today we are going to discuss the analysis of a constant angle arch dam based on thick cylinder theory. Now if you haven't watched the previous lecture, that is lecture 5, then I will recommend you to first watch that lecture, because in that lecture I have discussed the theory and discussed the derivations of thick cylinder theory. Okay, this is the practical problem which is based on that thick cylinder theory. So if you haven't watched that lecture, so the link is given here in the suggestion. Okay, so first of all, please watch that lecture, and then this this will be helpful to understand this particular problem. So let us begin now. In this problem, we are going to design a 120-meter high constant angle arch dam for a valley which is 50-meter wide at the base and 250-meter wide at a height of 120 meters. So now first let us draw a valley described here in this question. So this valley is 50-meter wide at the base. So this is 50-meter wide at the base, and it is 250-meter wide at a height of, so this is the width, this is the width 250 meter, this is the width 250 meter, and this is at a height of 120 meter. Okay, the permissible compressive stress is given 500 tons per meter square, and we will be assuming the minimum thickness to be 2.5 meter. Okay, so suppose that this is symmetrical, so this will be 50. Okay, and this will be 100, and this will also be 100. Okay, suppose at a depth of h meter, okay, from the top, this width is x. Okay, so this is the total depth 120 meter, so the remaining will be 120 minus h. Okay, and the span is L at this level, h from the top. This is the L span, total span. Okay. So in order to determine this x, we can say that x over 100 will be equal to 120 minus h over 120. Okay, so this will be 100 120 minus h over 120. So this will be 10 over 12 or further we can say 5 by 6. Okay, so let us write it 5 by 6 into 120 minus h, and x will be equal to 5 by 6 times 120 minus 5 by 6 of h. Okay, so x will be equal to uh, 6 20 so 100 minus 5 by 6 of h. Okay, this will be the expression for x. Now in order to calculate the span L, so L is equal to 50 plus twice of x. So this will be equal to 50 plus 200 minus 5 by 6 of h. So L will be equal to 50 plus 200, okay, minus 10 over 6 h. So this will be equal to 250 minus 5 by 3, not 5 by 6, 5 by 3. L. This will be the L. So remember this expression. We will use this expression later on. Now, if suppose this is an arch, okay, and this is the external radius, okay. So from here to here, say it is RE, and from here it is RI, and angle is 2 theta, okay, and this is thickness T. This is your arch, okay. So if this is the span L, okay, then this is the perpendicular bisector, okay, so this will be L by 2. So L will be equal to twice of Ri sine theta. Ri will be equal to L over 2 sine theta, okay. Now in our problem, we have in this problem we have assumed that our arch is constant angle arch, okay. Our arch is constant angle arch. So for this constant angle arch dam, we are assuming that the central angle 2 theta is equal to 133 degree 34 minutes, okay. So now let us put this over here. So Ri will be equal to L over twice of sine 133 degree 34 minutes by 2. Okay, so in this table, if we use the thick cylinder theory, and if you remember that in the previous lecture I have derived the expression for thickness to be equal to T equal to, and in terms of internal radius it is 1 minus under root 1 minus twice of P over sigma I over under root 1 minus twice of P over sigma I. Okay, where this T is the thickness of arch, thickness of arch. Okay, and Ri is the internal radius, internal radius. P is equal to gamma W times H, where gamma W is the unit weight of water and H is the depth of water from the top. Okay, this is the depth of water from top, and gamma WH is unit weight of water, and we are assuming it to be 1 ton per meter cube. Okay, so for our calculation purposes P will be equal to H. Okay, so here P will be equal to H. Okay. And sigma I is the permissible compressive stress, because this is the internal stress, so this will be permissible compressive stress, and this will be equal to 500 tons per meter square. So since our dam is 120-meter high, so let us divide our dam at 10-meter interval. So at the top the height is 0. Since the pressure, water pressure is equal to H, so this will be also equal to whatever will be the value of H here, the same will be the value of pressure. L is equal to, we have already calculated, 250 minus 5 by 3 of H. So this is equal to 250 minus 5 by 3 of H. So put the value of H here, whatever will be the value of H, you put it here, you will get the value of L. Okay, so for 0 it will be 250. For Ri, we have already determined the expression. It is equal to 0.544 times of L. So we have calculated the value of L in this column and multiplied by 0.544, you will get the value of Ri. Okay. Now in our expression for the thickness, we require to calculate this term 1 minus 2p by sigma. Now here we have already determined the value of pressure P. Okay, we will put the values from each row, and sigma I is equal to 500. Okay, so this will be 1 minus 2p over 500. So for first it is 0, so this will be 1. So I have calculated for each this term for value of operation. Now to calculate the value of thickness, we need Ri. So we have already computed Ri over here in this column, and we also need this term. Okay, this term. So we have already determined this term. Say this term is K. So this will be Ri 1 minus K over K. Okay. So here K is 1. So 1 minus 1, this will give you the thickness 0. But remember that we cannot put the 0 thickness. Okay, we cannot provide the 0 thickness. So here we have to ensure the minimum thickness for an arch. So the minimum thickness that we have assumed is 2.5 meter. So this will be 2.5. Okay. For this, it is and finally the external radius RE is equal to RI plus T. So here Ri is this and T is this. So we will add both these columns and we'll get the external radius. I hope you have understood the stepwise procedure to calculate the thickness of a constant angle arch dam based on thick cylinder theory. So if there is any question, uh, then I would like to answer your queries. Please post your questions in the comment box. Thank you students and goodbye for now.